Spoofing is pretending to be something that you're not, and there are several different ways that you can spoof, and we'll look at some of these. Again, spoofing is the act of falsely identifying a packet's IP address, MAC address, etc. Generally, well, it's pretty much always the packet's IP source address. That's what you're usually going to see. There's four primary types of spoofing: IP address spoofing, ARP spoofing, and this involves media access control addresses, web spoofing, DNS spoofing. So there's a lot of opportunities out there for something to be spoofed. IP address spoofing can be used to exploit the trust relationship between two hosts. What we have here is there are certain applications and certain operating systems that actually you can go in and say, if a packet comes from this particular IP number, it's to be trusted, it's a legitimate packet. And one thing you can should always realize about an attacker, or attackers in general, is they will use anything and everything against you, and anything that makes your life easier also makes their lives easier and enables more attacks. So this trust relationship concept makes your life easier, and it also makes it easier for them to attack. And I'll show you an example of this later on in this presentation. This trust relationship we're talking about here could be enforced at the router, the firewall, by an application, or by the operating system itself. Now, the attack, I should put that in there, the attack involves creating an IP packet with a forged source address. And again, we'll look at this here in a moment. Now, there is, or are, IP spoofing attacks. They can be done. Doesn't necessarily mean that they're terribly easy, but here's some of the problems that have to be overcome on this. It is easy to craft packets and to spoof IP addresses, and we'll try to look at a packet crafting application later on in this class. It's easy to craft the packets and spoof the IP addresses, but the attacker can't create a situation in which the return packets will be delivered back to him or her. The return packets are going to go to the spoofed IP address. So the packets actually go here, and not to the attacker himself or herself. The return packets will be delivered to the trusted host, which could reset the connection and foil the attack. If you remember, I think I've mentioned this somewhere or other, to set up a connection using TCP and TCP over IP, there's the three-way handshake that goes on. The initiating computer sends a SYN packet, synchronized packet, and its initial sequence number. The receiving computer acknowledges that and sends its own send packet and its own initial sequence number back to the initiating computer. So that's the SYN-ACK part. And then finally the initiating computer sends back a final acknowledgement of the receiving computer's sequence number, and then you've got your connection established, and we can start sending real data across. Now, if a computer is just sitting there on the listing on the network and it receives a SYN-ACK packet, it will check and to determine if it actually has actually sent out a SYN packet, the previous SYN packet that corresponds to this. In the case of this attack, it will not find that it sent out a SYN packet. So if the trusted host sees the SYN-ACK, it will basically say, I don't know what you're talking about, and it will send a reset acknowledgement, a reset ACK packet that will tell the computer that's actually under attack to basically reset the connection and so foil the attack. So the attacker must make sure that this does not happen. And you can write this down. We'll look at it here in a minute. The attacker must prevent this from happening. And another problem, the packets sent to the victim, let's put an asterisk here, from the attacker must have the correct sequence number. So here's your problems if you're going to do an attack like this. You send a packet to the computer you're attacking, and you're spoofing the source IP address of. You're using this source IP address of a trusted computer. You got to make sure that the packet that the attacked computer, or the computer under attack, sends back somehow is not processed by the trusted computer, because if the trusted computer actually sees it, it will realize it didn't initiate this conversation, and it will stop the conversation. At the same time, the attacker must feed succeeding packets to the computer that's under attack and correctly guess the sequence numbers. Well, actually, it's not so much of a guess. You'll see in here. We'll talk about this in a moment. So these are some of the problems that the attacker has to overcome. But it's not impossible. So we have a graphic to help us see what's going on here. Now, here's the attacker down here, and this is the computer. Let's see which one's under attack. Yeah, this is the one under attack. This is the victim. Victim is up here. So, the first thing the attacker is going to do is do a SYN flood attack against the trusted host. This is the trusted host. And the victim trusts 10.1.1.1. So, the attacker sends a SYN flood against a trusted host to shut it up. Now, if you remember back when we talked about SYN floods, this is a denial of service attack. So there's actually two attacks going on here. We've got a denial of service attack against the trusted host. And the whole object here is just to shut it up. We don't want it to be able to respond. So that's what happened first. Second, here, the attacker creates a packet with the source address of the trusted host, which is 10.1.1.1. Sends this to the victim. Now, and this will be a SYN packet. The host, the victim under attack here, will reply with a SYN-ACK, and it will be addressed to 10.1.1.1. So the reply packets come over here, and this is why we had to shut up the trusted host, because ordinarily it would see the SYN-ACK and basically send back a reset acknowledgement saying, I don't know what you're talking about. Meanwhile, we've got the trusted host under a SYN flood here, and it can't respond. So number 4, the attacker must guess the contents of host A's packet and craft an appropriate reply. So it must, what the attacker does, it has to guess the initial sequence number of the victim. Now, recall how TCP works. The victim will generate in a number, the initial sequence number, and send it in the return packet that actually goes up here to the trusted host. When the attacker sends the next packet, this is going to be it's going to send an ACK packet, and it has to, in this ACK packet, guess the initial sequence number of the victim. Now, I say guess here, and I put it in quotation marks, because when any computer, not just the victim computer, picks an initial sequence number, it's not a truly random thing. If you study computer science very much, you'll repeatedly run into this concept of it's hard to really truly generate anything random in a computer, because you have to write the program code to generate whatever you're generating. In this case, we're generating a number, a 32-bit number. So the fact that you have to give it something to start with makes it not truly random. The best you can hope for is what we call a pseudo-random. But that's still not a truly random number. And what usually happens when a computer generates these initial sequence numbers, it will be an increment, a certain offset from the one it used before. So what the attacker will do is it will try to initiate a sequence with the victim, see what the sequence number is, and then it will initiate the attack. The initial connection will not be allowed to continue, because the attacker is not trusted by the victim, but the victim will it has to go through the three-way handshake before it can get to the point where it decides whether it wants to really talk. And there's several ways the attacker can do this anyway, but somehow or other the attacker has to get some sense of where the victim is in generating these initial sequence numbers. And then the attacker basically guesses based on what it saw happening before. And again, it sounds complicated, but it's not that bad. Attackers actually can pull this off. So if the attacker is successful with guessing the initial sequence number of the victim, from that point on, the attacker knows what it's sending. The attacking computer or the attacking software, this is usually automated, knows what it's sending and can calculate what the response is going to be, and therefore adjust the acknowledgement numbers appropriately. Because basically what you're doing here is you're communicating with a computer, the victim. You're not seeing the replies from the victim. And if you don't send the right things to the victim will basically figure out something's going wrong and could terminate the connection. So the attacker has to do a certain amount of guessing and a certain amount of calculation based on what it's sending. So the attack itself, once the three-way handshake is completed, tends to be very short and directed at establishing, sending an exploit to the victim, and then basically having the victim computer present like a command shell back to the attacker, and at that point we really don't have to worry anymore about the spoofing thing. The spoofing is just to get the exploit over there and get control of the computer. So those are all the steps involved in an IP spoofing based attack. And again, it looks complicated, but it can actually be done. And the attackers know this, and they've got they've written programs that actually help them do some of this, because you have to be fairly quick about this, or your connection will time out and reset. But these happen, and I just wanted you to be aware of all the different pieces and things that have to be done, things that have to be taken into consideration, etc. Now, you may, hopefully, from listening to my explanation, realize that it takes a pretty good understanding of what's going on with the TCP protocol and even the IP protocol to understand this attack. I mentioned this to you before. The attackers, the really good ones, understand what's going on with these protocols. They study the response of computers to various sorts of packets and situations, and they will use that against you. And in a lot of cases, they'll actually write programs that will help automate the task, and then lesser attackers with lesser understandings of what's going on can actually use the programs that were written by the people that really, the top level attackers. So if you want to be really good at understanding attacks, defending against attacks, you really need a good understanding of the TCP and IP protocols.